Hello everyone, it's November the 18th. Alright, let's go into it. Find all numbers disappeared in an array. Huh, have I done it before? Oh, it's a fresh new question. Given an array of numbers, and I is in the range of 1 to n, return an array of all the integers in the range 1 to n that do not appear in nums. Huh? So ni is in the range 1 to n. Oh, 1 to n. Oh, n is the total number of. Oh, so this is what? 1, 2, 3, 4, 5, 6, 7, 8. So everybody is 1 to 8. The return array of all the integers inside that do not appear in nums. Without extra space in the O(n) time. Okay, so definitely we are going to move them around, right? Because we have n numbers, so every one has its space. So 1, we can move it to here. So actually we can go like 4. Yeah, we can move 4, we'll move to the third place. 0, 1, 2, 3. Let's move 4, move here. 7, move here. Yeah, I can do this. Actually, we need to add one more space, right? We need to add one more because 1 to n, we have n space. Yeah, we need to add one more space. So 1, 2, 3, 4, 5, 6, 7. We need to add one more space. So add 8. We have 4, 3, 2, 7, 8, 2, 3, 1. We add one more space to hold 1 to n. Actually, no. We don't have to add another space. We simply just modify the value. So 4, we need to move to the third position, right? So move to third position. Okay, so now when we move, we turn into 0. No, actually, we turn to -1. And then now it's 7, so 7 move to its position, so move to 7. So, and then this is 1, we'll move to 1. Alright, that's it. So we'll go to the next one. 3, move to 3. 2 moves to 2. Right, that's it. Keep going. 8 moves to 8. So 8 move. Oh, actually, we got it wrong. Shoot. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I got it wrong. I'll do it again. 4, 3, 2, 7, 8, 2, 3, 1. So 4. Go to the fourth position. -1. 7 goes to 7th position, which is actually here. And then 3 goes to the third position. 2 goes to the second position, and 3 goes to the third position. Doesn't matter, right? Now we go there. When we go there, we find out that this value is either -1, right? Now we stop, or if the value is itself, then we stop. When we stop, we just keep moving on, right? We keep moving on. So we keep moving on from where? From where we started, right? From where we started. And then we keep moving on. If it's fit, then we keep moving. Now 8, okay, 8, we move to here, to the last one, and 1, move here, and done, okay? So we keep moving forward. Move forward, that's a -1, because we move from 8. Doesn't matter, we move forward. That's a 2, we move to its position. Stop, move forward. 7 is good. So we have 2 values, which is 5 and 6. Yeah, that will work. That will work. All right, let's do this. Ting. All right. So what we're gonna do is I equals 0, right? And then while I smaller than len nums, we're gonna do another loop. I'm gonna say while nums I, right? While nums I is not equal to I plus 1, and nums I is larger equal to 0. So I'm gonna set it to, oh, I can set it to 0 because 0 is not gonna appear. Right? There'll be no 0. I'm gonna start from 1. So I can set it as sentinel to 0. So we just say while nums I and nums I is not equal to this. That means we need to swap. Right? How do we swap? So we're gonna swap with the value. So we're gonna take this value out, swap to that value. Oh, actually, maybe swapping is a better idea instead of jumping back and forth. Yeah, let's try swapping. So what I mean swapping is we say 4 going to swap with this, right? So we swap. After swap, then we still add this position. And then 7 going to swap with this. Still at this position. 3 swap. Add this 3 swap. And then 2 swap. And then 3 swap. And then we cannot swap, right? So this 3 we cannot swap. Once we cannot swap, why we cannot swap? Because swapping is a better idea. Let me see. How do we do this? So while this is not equal to, then I can swap, right? And if it meets the same, like it's 3, and it's 3 is already, so we cannot swap. So once we cannot swap, I just set it to 0. Yeah, that should be fine. Okay, so while this, now we just say nums I, right? Well, swap first. We need to see if they are the same, right? So we say if nums I is equal to nums I minus 1. That means they're the same. If they're the same, then nums I equal to 0. Else nums I nums. Oh, let's set a temp just in case. It's hard to handle. So what's the temp? So now it's saying so I need to go to that position, right? Go to that position. So temp. Position will equal to nums I minus 1, right? So we're gonna say nums I nums position equals nums position nums I. So this is swap. So nums I nums position swap, right? And after swap, we'll go back up, right? If it is equal to what it is, then we stop swapping. Otherwise, we check. So this one we can actually do it earlier. We can do it here. So this one just be position, right? So if the position is equal, then we set nums I to 0. So go back up, we'll break out. And once we break out, always I plus equal 1. So the next one. So for every single one, we'll swap until we cannot swap anymore. So we cannot swap anymore. Either I'm in the right position, or there's a duplicate, I set myself to 0, right? And then, once it's done, I'm increment I to the next one. So I will swap, and at the end, we just need to count, we just need to go through. So we return a list, right? And say for any nums, If not, if n equals to 0, then actually we have to do I, enumerate, all right? We're going to return I plus 1, okay? All right. We have this. Answer is 5 and 6. Next one's 1 and 1. Answer is 2. Okay. Nums. Find nums. Okay, so they pass. Edge case. What type of edge case are we talking about? Well, this, right? It should be empty. Yeah, so that should be fine. So this is, let's go with it. Yep. Oh, but so slow. Why is it so slow? So this is code. Yeah, this is way slower than I expected. So this is swapping. Maybe we can jump. I can't jump. I have to go one by one, right? So we're swapping. Should be O(n), O2n, right? But the runtime is just abysmal. 416, 26. I'm pretty sure the faster one will be. I mean, we just want to know which one does not exist, so we can just. How would you do it if there's no restriction? Well, if there's no restriction, we can take a set. I'll take a set. We just sorted it. Yeah, sort doesn't really work. Oh, it does, right? It does. Sort does work. We have to go one by one. Interesting. Oh, 6 solutions. Brute force. No. Sort. Binary search. Wait, how do you binary search it? Oh, no way. You just go one by one and binary search every single one. Jeez. I don't know if I like this idea. Where's the binary search every single one? The binary search every single one. Hash set. Yeah, this is what I had in mind. We counter it, right? And we just go one by one. Maybe this is the fastest. Boolean away. Yeah, that's a bucket. Right, a bucket. Placing in the correct position. Is this not in place? Alright, it seems to be easier. Oh, this could be a for loop. I agree. While they're not equal, we're gonna swap. We'll swap until they're equal. how? Nums and I, they wait, in my situation, we will have a case where they will be equal. Like I am like at position 1 as a 3, and then I have a 3 later on, and decide I want to. So you can swap. A swap, it's gonna be infinite loop. Really? I don't know. Right, we swap 4, we swap here, so this will be 7. 7 swap this will be 3. 3 swap this will be 2. 2 swap will be 3. And 3 swap will be 3. 3 swap will be 3. Oh, it's not checking with myself, it's checking with, now I see. We're checking with, so if I am not the same, that makes sense, right? If my supposed location is not the same value as me, now we need to swap. And once I finish, everything's fine. I'm finished, then my location will be the same as, yeah. Eventually, it will happen. We will go for like a duplicates. Yeah. So it can be a little bit easier. So we don't have to reset the value to 0 or anything like that. Oh, good solution. I think I'm gonna write that. Yeah, I think that's good. It's better than, it's clearer. It's more clear. It's clearer, right? So solution 2. Better while loop condition. No need to set a sentinel from here. All right, so what do? We say for I, okay, for I in range land nums, right? And I say while nums I is not equal to nums, I don't like it. I like position. Nums I minus 1. Right, so if not equal to position, then we swap nums I, nums position equals nums position, and nums I. Alright, so swap, and then we return. It's the same thing. Return this. And return this for blah 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 if n is not equal to I plus 1. So solution 2. Oops. We have issue. Oh, I cannot do it that way because every single time we have to reset. We have to reset the position because everything's changed. Right? It's changed. Nums I has changed. The position has changed. Which means we can set a position inside, but while nums I is not equal to this nums this, so we're gonna swap. I think the swap order matters now. So this one, I'll change num's I first. Yeah, I do think order matters. This one has to go first. Because we do this, we do not change num's I. Otherwise, num's I will be changed. Then the position change. This one does not. I just change this value. Num's I does not change. Yeah. The temp value is num's I. Right? So temp value is num's I. So therefore, this one works. So num's I is temp. So this one we can do, and then num's I equals this we can do because num's I is already cached. The other way does not work. Okay, let's see how fast this one goes. Yeah, about the same. Alright, so that's that. I'm gonna roll another one. Yeah, I'm like a bit debating. So yesterday we saw the medium question. The next medium question is bash. I don't know if I want to do it. Well, the reason is I'm pretty sure I won't be able to do it. It's hard. Talking about rotating. This is by looking at it, I have no idea. I mean, we basically have to grab a column. How do we grab a column? You know what? I'm not going to do this because I feel, well, the previous one, maybe it's okay, like the word count. This I feel just stupid. I mean, I don't know how to do it, but I just feel stupid. There are so many other tools to do this. Right? You don't have to use bash. I am curious of the solution. Well, we just, I don't know, like read a line and what? Okay, I have a solution. We can write to a temporary. Oh, we can write to an array. Right? I can read a line and append every single one to an array. Read a second line, append it to an array, and eventually we just print out the array. But if you do this, what's the difference between doing this and using Python? Alright, I'm gonna just take a look. I'm not gonna do it. And a statement just like C. No scripting in bash. No array matrix. Pure bash. Ooh, what the heck? You can append string easily. So awk I is 1, I is 1, what's NF? If NF equals 1, S this equals this, else S this equals this. Okay, this is building each row. And for this, I'm gonna print this. Alright, I need to explain. That just means it's the first one, right? So we read the first line. We're gonna input current is name. Alright. The next one is age. nr is still 1. npar will run after deal with every line. After dealing with all the lines, the S array is what we want. npar is to print yes. It's for loop n when inside is empty. Huh. I'm not sure. I'm not sure I understand. This is appending, so I can see how you append. But name and age appear on the first line. And we read name as 1, age as 1. So we read name as 1, and age as 1. And then I read Alice. Oh, maybe this is number of rows. And I read Alice, and I put it in, and I read another one. I put it in. It doesn't make any sense. Code block with an end prefix is executed after the last line is read. Code block with beginning. Before I know this from last time. All is line based. The main code block, the code block without prefix, processes one line of input at a time. A variable indicating the number of records, current line number, that's accumulated across multiple files read. It's similar to this, but is reset for each file read. We only need to deal with one file, either is fine to use. So NF is a variable indicating the number of fields. Number of fields, number of column of an input line. How do you determine the number of columns? Is that just number of values separated by a blank? The ith field of the input line. Okay, let's just say that's a Gawk array. So we say for each line, we'll read from the first to the last field. And we say if it's the first line, first row, right? Then we're gonna set ti to the first. Elsewise, we're gonna say it's gonna be ti and end this, and then we do the current one. Okay, up to now I follow, but then a second field comes in, right? T2. Oh, I think I know. So the T, Ti, I is the column, and each column represents this is a string. So each column represents a string. So each array is a string by itself. All right, let's take a look. Oh my god. Where is as the array? I lost interest. So I think I know, right? So we have like two fields. So grab the first field and then set it to, so T is a table, right? So the first field will be this value. And then I read the second field, right? So each line, the second field. And if it's still the first line, then we set it to a new field. So T2 equal to the header of the second column. And then we're going to the second line, then I to this, and it's not this, so I just append, and I append, and eventually I print, right? So print, TI, that's the table. It's an array of saving the transpose table. And now I understand. Would I use this? No. No way. When it gets this complicated, if I port it into Python, I'll do exactly the same thing. I'll read each one. It's the same program. If you think about it, if I do it in Python, it's the same program. So, I don't know. I don't know what to think about this. But no, I'm not doing this. Let's do this number of islands. How about that? Oh, wow. People love this question. I don't know why I do this. I chose this problem because I have not done it before. I mean, click this. It's useless. All right. Given m by n 2D array grid represents a map of ones and zeros. To the number of islands. The number of ones. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. I'm going to assume all four edges of the grid are all surrounded by water. So this is 1, because this is a giant island. This is 1, 2, and 3, because it has to be connected vertically or horizontally. Nice. It is a good question. So how do we go with it? Well, traditionally I would just say, I don't know, DFS, right? We DFS, so we'll go here for every start, and we just go, right? And then we can go, just keep going when we cannot go, and now go, just backtrack. So yeah, we go this, we color, right? We color. Yeah, so if it's connected, we can start from any position. We can start from any position, and then we can just expand. The color can expand, and it will color everything. So everything, we start from here, we will color the entire thing. So once we're done, we can mark it as a value, right? Mark it as a value. Doesn't matter. Doesn't matter what value it is. A sentinel, a -1. And then when we're done, and then we simply just, once we're done with this, we just keep searching until we find another one, and we will expand as well. And then, yeah, that's pretty much it. I think DFS will work. So this one is 200. Okay. Code 200. Should we test this? It's hard to test because it's a grid. That doesn't matter. We're gonna test it. I think we'll test it. So, like usual for this type of question, we grab mn first, right? And I'm gonna modify the grid. Oh, these are. Oh, I can just do empty. Yeah, that's fine. And how do we decide when? Yeah, I have to like branch out, and then we'll go back. So the initial, right? The first one, right? The first one. So anyway, so we're gonna DFS, DFS. We're gonna I, J, right? We're not gonna return anything. There's no return, right? So all we're doing is, when we first check, not check, just like at this position, right? At this position, I am going to mark myself, right? Mark myself, I say grid ij, will mark myself as a, oh, we can mark at a 0. We can mark at a 0. And once I've marked it, I'm going to check my surrounding, right? I check my surrounding. So, let's say for ni, nj in, so I plus 1, j, I minus 1, j, I, j plus 1, and I, j minus 1. Right? So, if 0 smaller or equal to ni, I see. We also, yeah, this is something, yeah, we'll do it here. If 0 smaller to I, smaller to m, and 0 smaller equal to j, smaller to n. Once we do this, then we do DFS ni and j, right? Which I just realized might be easier to write. We'll just say DFS this. Just do it 4 times, right? DFS this, and we don't have to worry about repeating ourselves. So we do 4 DFS. Let's do 4 DFS. So if this, and don't forget, grid ij has to be equal to 1. Right? If it's 1, then we keep going. So that is the DFS. So what we're going to do is res 0 count, right? For I in range m, for j in range n, right? We call DFS, right? We call DFS. Hey, that's actually, how about we return an integer, right? So we say if this, we are going to return 1. If not, we return 0, right? So, which means if I find 1, we'll always return 1. Right? It doesn't matter. These will all return 1. It isn't asking us for how big it is, right? So we just return 1. If it's nothing, I just return 0. So we can just go res plus equal to DFS ij. And then we can just return res. Or, even better, I think we can do this. So we're going to return sum for I in range m, for j in range n, right? And then we just do DFS ij. All right, let's try it. Yeah, basically this is just, we need to take everything into 0, but we need to return a value indicating that, okay, this is good, right? This is good. So, ooh, the test case will be interesting. So first one, we're gonna have this. Oh my goodness, look at that. How am I supposed to reason with that? You find a way. There you go. That is the way. And this is the result. My lord. Okay, second one. All we need to change is this. Yeah, it's gonna look ugly. Not too bad. That will be 3. And our grid. And so this is num islands grid. Yep. I mean, technically, we can even put this No, I can't. Can I? Can I? Can I? I just want to write these 4 in one line. All right, that's what I want. I want to write them in one line. How do I write them in one line? I mean, we can just do like this. That will make them in one line. Well, they either would return 1 or 0, right? So return 1 or 0, so I can just or. All right, as long as one of them is 1, it will become 1. I can just return one or this. Can I do that? I just want to write it in one line. That's all it is. Yeah, this is it's not evaluation, so it will go through every single one. So yeah. What would be the best way? No, I don't like it. I'd rather do this. N-I-N-J. Yeah, I like this one better. I plus 1, J, I minus 1, J. I like this one better. I, J plus 1. It's like a combination of all the methods I've seen, right? So with this, I just do DFS N-I-N-J, but I don't have to return anything. And we just return 1 at the end. Right? So we do make it simpler. Okay? Alright, go for it. There, that's it. So it's just DFS. DFS, since we only need to return the number, right, the total number of islands, the problem is actually simplified. It's actually simplified. So runtime will be OMN, right? Every single cell is visited once, and sum twice. So we go 336 milliseconds. Oh, jeez. 336. 49. Okay, let's see. Any smarter idea? Yeah, will be similar. It says 7 lines. This one will be like 1, 2, 3, 4, 5, 6, 7. Map. Map. A function and 2 arrays. How do you... yes. Yes. So, but this syntax is still I know, this is the 4 directions, right? But we put these two. Alright, I need to see map. See, that is the benefit of reading these people's solutions. Map. Return an iterator that applies function to every item of iterable, yielding results. If additional iterable items are passed, function must take that many arguments and is applied to the items from all iterables in parallel. With multiple iterables, the iterator stops when the shortest iterable is exhausted. It's already arranged into items tuples star map. So this means this map will take the first one of this, the second one of this. Oh my goodness, this is so good. This is so good. Yeah, we do have the same idea. It's actually exactly the same idea. It's just I'm using this. So, oh, Mr. Pachman. Yeah, I have to go to list, map, DFS, and then we're gonna have two lists. So first list is I, so I plus 1, I minus 1, I and I. J will be J and J, J plus 1 and J minus 1. Oh my god, this is so good. Oh, so this is courtesy of Mr. Pachman. Man, how do you know all this trick? Do you like just read the documentation of how it works? You know, the map is really good. That was a long time ago. 2015. Wow. DFS. This is when the first thing started, 2015. Everybody is like old, really old. Roger Federer. 2020. Ah, he posted 2020. I guess for fun. Union find. Oh, hold on. Union find. So we know DFS. That's fine. BFS, I guess, is fine too. Union find. And of course, path compression. Wait. Union find path compression. Union find path compression. I just want to know the general idea. So these two union find is the same, right? Union. Oh, that's probably union find with rank. Yeah, it's with the rank. It's union find with rank. Anyway, that's the directions. There's this union find m times n. The parent, and the size, So for everyone, okay. If it's this 0, if component, if it's not 0, component plus equal to 1. What is a component? It's a total number, okay. Current ID, that's just flatten the array. If we're in 4 directions, I know the next directions. If the next direction is bad, I'll continue. If it's good, next direction, ID, neighbor ID, and when a union, current ID and the neighbor ID, yes, they do belong to the same union. And we need to check. So union will return true or false. So if it's true, why would it be false? False is when they are already together. I shouldn't say already together. They already are part of a union. If they're already a union, now return false. If they're not a union, then we all will merge, right? So we compare the parents, and then parent PU, the size, it's the ranking. So one of the ranking will plus equal to the other's ranking. So if this one's smaller than this, so we'll plus to that ranking. Otherwise, we'll do the other way, and then we're gonna assign the one with a higher ranking, right? Not the same, so one of the parent, so parent PU will equal to this, to someone with a higher ranking. And if PU is larger than, so PU is big, oh, I should make the big one bigger. So the parent is ranking is smaller than this ranking. I should even increment this ranking, and I assign this. I'll assign this. Just make sure, so every time if they have different parents, right, then we just assign one of the parents parent to be a higher value. And then, because we have path compression, next time when we go here, it will be compressed. Very good. And return true means we merged. So if it's merged, we don't do anything. So the next one come out. So the first one come out, component will be 1. And next one come out is actually going to be 2, right? And then the next one come out. Then when the union, and the union will find they already belong. Well, they might not belong, but yeah, because as I add new ones, they do not belong. So initially, they belong to themselves, right? So yeah, so the first one come out. It's actually no, the first one come out. Right, I have an ID, and then I'll go its neighbors. And out of its neighbors, we're going to try to union it. If I can union it, the first one union will not do anything. And the second one union will not do anything. So these 4 unions, if it has not been union before, so all of them will not make any change. Because I component add, and I just do this. They will all be new addition. So once we're done, okay, come back up. Now we go to the next one, right? So the next one is likely something I've already unioned, but I add a component. And I already union, and I also go around, I go around to add everything. And then if it has already been unioned, then this one does not count. So we go through, so every time the component will add, but if that new one has union with something that's already been unioned, then I remove it. Unnecessarily convoluted, but it's fine. Man, if I need to explain union find, I have to really dig into this Ackermann function. Yeah, this is something I need to really look into. But anyway, I'm gonna upload it. I never thought about the union find. Alright, that shall be it. I just call it a day. I'll see you guys tomorrow. Adios.